Hi, my name's Kyle Tierney, and this is our first lecture series on Common Core geometry. We're going to go over some of the basic concepts today in our first lesson that will help you guys later on to master the more advanced concepts. And some of this terminology may seem a little bit basic to you guys. You might be thinking to yourself, well, why am I watching this video right now? And indeed, for some of you, it might be a little bit too basic for you to handle. You might be a little bit bored by this, but trust me, it's going to get harder, and it's really important for you guys to make sure that you guys master the basic concepts before you can move on to the advanced stuff. Because if you don't know the basics, you're really going to struggle later on with this course with the more advanced problems. So the first thing that we're going to talk about is the most basic concepts in all of geometry. It's so basic that you might want to hit yourself in the face after you hear this. It's just a point. The way that we label points in geometry is we draw a point like that, and then we give it a letter, and we call it A. So this point right here is called point A. Now, what happens if I stack a whole bunch of points, one after another, like this, and I put them really, really, really close together, infinitely many points next to each other, is I get something nifty called a line. Now, the interesting thing about lines are that they're straight, but also in geometry, what we do is we add these two arrows at the end of them. Okay, and what these arrows basically mean is it's a lazy way of saying this line goes on and on and on and on forever and ever in that direction, and it goes on and on and on and on and on forever and ever in that direction. And the reason why we have those arrows is because there's not enough paper in all the world to draw a line that never ends. And it would be pretty boring if we had to keep drawing a line forever and ever that never ended anyways. So we just tack these little arrows on here, and that just means, hey, this line is going to go forever that way, and it's going to go forever that way. But like everything else in geometry, we need to give it a name, right? We can't just have this line here because there are thousands and trillions and billions and millions and gazillions of lines in the universe. And somehow, when we're talking to somebody about our line, our very special line that we want, we need to be able to differentiate our line from all the other millions of lines in the universe. And the way that we do that is we give it 2 points. We'll give it a point right here. We'll call that point A, and we give it a point right here. We'll call that point B. So cool. And the way that we name this line, if you were to write it out in a sentence, is that this line is called line AB. So that's called a line. Now, there's another type of geometric figure that's very similar to a line, but it's not quite the same. And I'm going to draw it for you and see if you guys can figure out how it's different. So we'll start with a point right here, and then we're going to keep going like this. And now you notice that's a little bit different, but it's also pretty similar to the line AB that we just drew. And it's similar because it's got an arrow on this side, right? But then right here, instead of having that second arrow, we have a point. Well, what this arrow means is just like before, it means that this part of the segment is going to go on and on and on forever and ever and ever that way. But then this point right here just stops. It does not continue going on in that direction. So what we call this, where we have a line that goes only on and on forever in one direction, is we call it a ray. But just like before, there are millions and millions of rays in the world, and we need to come up with a way that we can differentiate this ray from all the other multitude of rays that are out there. This is our special ray. So what we do is we need 2 points again. So we already have 1 point right here at the bottom. We'll call that A. And we have a second point up here. We'll call that B. And so if we were to name this ray, it would be A, B, just like before. But unlike before where we had those two little lines on top to show that it's a line, we're only going to have one arrow on top, just like that. And the reason is because rays only go on and on forever in one direction, whereas lines go on and on forever in two directions. So we have two arrows on top of our name for lines and only one arrow on top of our name for rays. Cool stuff. Unlike before where we had two arrows, okay, on a line, or one arrow on a ray, this time we have 2 points. And that means that this line stops right here at these points. Doesn't continue on after that. And what we call this is a line segment. And just like before, we name it with 2 points. Let's pick something different from AB this time. Let's call this C and let's call this D. And so if we were to talk to somebody about our line segment, we would actually name it CD and we would give it a point on top, and then we would give it a second point as well. So unlike the ray where we had one arrow, and unlike the line segment, or unlike the line where we had 2 arrows, our line segments have 2 dots on the end of them. Cool stuff. Now the next thing that we're going to talk about is going to be a little bit different than the stuff we've been talking about before, because the last stuff was one-dimensional, but this thing that we're going to talk about this time is going to be two-dimensional. We call this a plane. And unlike before, where we had lines made up of dots, planes are made up of lines. In fact, you could draw a million different little lines, all snuggled up next to each other in this plane, on and on forever. And what you'll notice about planes is that we can't just pick 2 spots to define the name of our plane, because if we pick 2 points here, then that defines a line segment. If we pick a point here and we pick a point here, again, that just defines a line segment. So we have a little bit of a problem. How many points do we need to name our plane? And the answer is 3. We'll put 1 point right here, 1 point right here, and 1 point right here. And we'll call this A, B, C. And unlike lines, line segments, and rays where we had to draw the little lines with the arrows on top, what we're going to do is we're just going to label this plane A, B, C with nothing on top of it. There's nothing right there. So I've got a quick question for you. What happens if I put 2 rays together? Well, then I would get something like this. Here's going to be my point. And then I have a ray going up. And then I have my second ray like this. Okay, and here's going to be 1 point. We'll call that B. And I've got to label my second point on my ray. Let's call that A. And I have a third point on my ray. We'll call that C. We actually call this, when we have 2 rays that are connected to each other, an angle. And believe it or not, this little loopy area in between the 2 rays is called the angle measure, which we denote by theta, and it's measured in degrees. So for example, this little area right in between our 2 rays could be 50 degrees, or it could be 70 degrees, or it even could be 40 degrees. So degrees are the way that we typically measure our angles by. If you've ever thought of like a skateboarder doing a 360, A 360 means that he's rotating his skateboard by 360 degrees all the way around. Now, just like before with line segments, rays, planes, and all that good stuff, what we need to do is we need to come up with a way that we can name our angle. And the way that we do that is we give it a little angle symbol, just like this, and then we pick the points. So we always start up top here, that'll be A, and then we go BC. So this particular angle is called angle ABC. Now, there are a few very special types of angles that we need to talk about because not all angles have the same properties. And so the most important type of angle that you guys need to be familiar with is what's called a right angle. And a right angle is where we have two rays that are perfectly perpendicular to each other. So if that's A, B, and then this point C, then our angle ABC is going to have a very special measure, and that's going to be 90 degrees. And in fact, this angle is so special that we don't just draw a circular little loopy line here to signify that it's 90 degrees. What we do is we draw a square like this. And that signifies, without even having to label that it's 90 degrees, that this angle is 90 degrees. This is a very special type of angle, right angles, because it pops up over and over again in geometry. There are so many different right angles and shapes, whether it's squares or rectangles or any type of geometric shape you can think of, triangles, they all have right angles in them. Oftentimes you'll see this popping up over and over and over again. So it's important to get familiar with this type of angle because you're going to be seeing more and more of it. Now, the second type of angle that you guys need to be familiar with is called an acute angle. And an acute angle is just a smaller angle, like this. So here's our points, A, B, C. And an acute angle is an angle that is less than 90 degrees. So it could be 30 degrees, it could be 89 degrees, it could be 20 degrees. As long as our angle measure is less than 90 degrees, then we can say that we have an acute angle. The minute that our angle becomes 90 degrees, it stops being an acute angle and it turns into a right angle. So it has to be less than 90 degrees. It could even be 89.99999 degrees. It doesn't matter. It's still an acute angle because it's less than 90 degrees. And again, the way that we're going to label this angle is going to be angle A, B, C. Now, if we have an angle called an acute angle, that's an angle less than 90 degrees, then what happens when we have an angle greater than 90 degrees is we get what's called an obtuse angle. So let's call that point A, let's call that point B, and let's call that point C. When we have an angle greater than 90 degrees, so it could be 91 degrees, it could be 110 degrees, it could be 150 degrees, it could even be 200 degrees. As long as this angle measure here is greater than 90 degrees, then we have what's called an obtuse angle. And just like before, we're going to name this angle ABC. The last angle that you guys need to be familiar with is what's called a straight angle. And as you can guess from the name, a straight angle is just where you have one ray and then you have another ray going the opposite way, so it makes a straight line. And in fact, a straight angle and a line are exactly the same thing. The difference is that we're picking one point in between them. So we're going to have A, B, C. And if before we drew an angle like this and it measured 90 degrees, then this section right here is going to give us 90 degrees. And then if we go over here, then this section is also going to give us 90 degrees. So if we add up both, a straight angle is going to give us 180 degrees. So this is called a straight angle. And we name it exactly the same as we did all of our other angles. We give it the little angle mark and we go angle A, B, C. And it measures 180 degrees. So let's do some practice problems on our own. Pull out a sheet of paper and we're going to see how much you can remember from the earlier part of this video. So what is this geometric shape called and what is it named? Pause the video real quick and see if you can figure it out on your own. Okay, this geometric shape is called a line because it has the two arrows on either side. It goes on and on forever in either direction. And it's named line CD. And don't forget that we have to add the two arrows on top to signify that CD is a line and not a ray or a line segment. Question 1. What is the name of angle 1? That's this angle right here. Pause the video real quick and see if you can come up with the solution. So if you answered that angle 1 is named angle ABD, then you're absolutely correct. We find a point on one ray and then we go to the middle point, that's B. So we start at A and then we go down to B and then we end on a point on the second ray and that's D. So we have angle ABD. My second question for you is what is the name of angle 2? That's this angle right here. Pause the video real quick and see if you can come up with an answer. Okay, so if you answered angle DBE, then you are absolutely correct again. Again, we start on one ray, okay, that's point D, and then we go to the midpoint, that's B, and then we end on the other ray, that's E. So we go DBE, angle DBE. Nice job. What we say is when we have two lines that hit each other in space, is we say that they intersect. And so this line might be named AB, and this line might be named CD. But then notice that when these two lines collide, they make a point of their own in the middle. Let's call that E. That point E, where the two lines collide, is called the point of intersection. It's where the two lines collide with one another. And if we have two lines that lie in the same plane, we say that they're coplanar because they share the same plane. Now, if two lines can intersect each other, it would make sense that two planes can intersect each other, and indeed that's true. So when we have two planes that intersect each other, so one plane is going to be the green plane that I drew, and the other plane is going to be the white plane. And the reason that these two planes create a line with one another and not a line segment where they would stop is because planes go on and on and on and on forever in every direction. So this plane goes on and on and on and on and on in that direction. And it also goes on and on and on and on forever and ever in that direction. And it goes on and on and on and on forever in this direction. And it goes on and on and on forever in that direction. Likewise, this second plane goes on and on and on forever in that direction. And it goes on and on and on forever in this direction. And up. And it goes on and on forever to the left as well. And so when these two planes intersect with each other, since they're both going on and on forever in every direction, they create a line that goes on and on and on forever in every direction, and not a line segment where it would stop. If these two planes stopped, then they would create a line segment, but they don't. So that's why they create a line and not a line segment. So sometimes we have two lines that don't share the same plane. And in this case, we have two planes here. They intersect with each other, but what I'm going to do is I'm going to draw a line that goes through this plane, like this. And I'm going to draw a second line that goes through the other plane, like this. And notice that they never intersect with each other, and they don't share the same plane. And when this very special scenario happens, we call this skewed lines. They're skewed because they never touch each other. They're just off from each other. They never share the same plane. They don't intersect. They're not parallel necessarily. They just don't really have much in common with each other. We call this skewed lines. Now lastly, we can have two different lines, one like this. Now lastly, what we can have happen is we can have two different lines that intersect with each other. But when they intersect with each other, they create four right angles. And if you remember, a right angle measures 90 degrees. And when this happens, when we have two lines that intersect and they create 90-degree angles, we call them perpendicular lines. Okay, thank you for tuning in today. The next lesson, what we're going to talk about is how to calculate angle measures and how to find unknown angles when we have certain sets of lines and line segments with one another. So thank you for watching, and please tune in again to the next lesson.